Code on the Beach, thank you very much for having me here. These are all of our sponsors, and please be sure to go by and thank them. These kind of conversations aren't possible unless we have sponsors, so thank each and every one of them. I went through and talked to a bunch of them, got a nice t-shirt from one, and one of those things that you stick on the back of your phone that all the kids are about. Yeah, my son loves them things, but he's tore up like 3. All right. So who am I? I'm a developer, or I do a little bit of everything. My main focus right now is in natural language processing using artificial intelligence and machine learning. I do this with search engines and robotics and stuff like that. I used to work for Disney and currently work for Verizon as contract. So I do a lot of stuff. Is it not hot in here? So I don't know if you heard this or not, but the hotel's air conditioning is down for a lot of the top floors. So if you're staying here at the hotel, it's hot. Try hot gluing when it's 85 degrees in your room. That was fun. Of course, I normally throw this at the end of my slides. I have 4 kids, so I always include one of them in my presentation. And a lot of my IoT stuff, I'm at the end of it will demo stuff. But this is a live demonstration, so demo now. You can watch it at any time. All right, and there's how you have to say it. So if you do say colon and then whatever word, it'll actually show up on the board. Your name will show up on the LCD screen. There we go. That's right. I work for an amazing company called Osmo. I know it's a weird word. I don't know where companies come up with these words now. Yeah, that was not where it came from. It was some kind of Jedi thing. We had a whole thing about it. But Osmo is a great company. It's a sister, or it was a daughter company of another company called Osmo, which I worked for, or sorry, Modea, which I worked for before, which was short for like Modern Ideas. We work with telecom companies to solve device support. So when you call into Verizon, I don't know how many people in here would actually call into Verizon for tech support, but people do. And so we build these tools for agents to support calls. We also are doing answer systems so that we can preempt agents with calls using artificial intelligence and other things like that. Yeah. This is not the IVR systems before. This is after you get an agent, our tools help the agent answer your questions. Gotcha. So we listen to the call and surface answers and provide simulators and emulators for them to run through. So this is slides from a company. Company paid for me to be down here, so. All right, so now what we came to talk about, what is a Stranger Things wall? If you missed the 2 minutes beforehand, there's a Netflix show called Stranger Things that talks about how, or in the first season, this woman loses her kid. Her kid goes out in the woods to play and he gets lost and they can't find him. And then she notices that lights start coming on in her house sometimes and it just flickers. And then she finally realizes it's her son talking to her from another dimension or another world, or it's called the Upside Down. So she realizes this, and this is the realization of it. I don't know how many in here have kids, but if you lose a kid and then you find them, it's like, oh yes, I found you, and then I'm gonna scare me to death. So this is when she actually realizes that her kid's talking to her, so she builds this wall. And he comes up and he lights up letters, and that's how he can talk to her. And there's only a couple of scenes in the show that talk about this, but it really resonated with me. So why would I build one? Well, this awesome company that I just talked about, we have a yearly Christmas party. And as an engineer and a robotist and other things, I use this time as as a way to get in and try to build props or trade show kind of things. So like the year before this one, I built this crappy robot that has 3D printed eyes and a mouth and shows videos on the TV screen of old sci-fi flicks, because that was the thing last year. This year's thing was Strangest Things. and it was 80s related. This is an L-wire sign that one of another coworker built. So we build these things and use this as kind of a way to explore new technologies and do things that we normally couldn't do, but still have fun doing it and benefit the company. This was the dance floor and kind of the theme. So you can see we kind of went with the snowball, and if any of you haven't seen the second season, sorry, spoilers. Also, I have a lot of GIFs in here, so if you're epileptic, close your eyes. You can still listen, just close your eyes. So we danced a lot, we drank a lot, we had a lot of fun. It's a great company to be with. We're hiring. Now back to the talk. So why did I make a tweetable wall? Well, I thought that taking the show's theme, Twitter was kind of like our upside down. You know, there are people on Twitter that can be whoever they want to, and they say nasty things, and they really have no regard for whatever they're doing. So it's kind of like this other universe that you can talk to real people with. So that's why I thought this fit perfectly, because Twitter, you know, matches that. And having this board just manifest things from Twitter kind of realizes what the show was talking about. Plus, when I mentioned this idea to people, they were like, "Ooh, wow, how can you do that?" That sounds really cool. And I live by this saying that any sufficiently advanced technology is indistinguishable from magic. And I had a job interview 3 or 4 years ago, and I was like, I like to be a magician with code. But, you know, if you talk to other engineers, it never works out that way because they know all the secrets. But if you talk to regular people, they think what you do is magic. So we're the modern day sorcerers. Now, the reason that I give this talk is because everybody who knows how to code can also build things like this. It's a soldering iron and a chip, and then you plug it into your computer and you program it. So this is the manifestation of being able to bring code into the real world. So I also like to work with wood a lot. I recently built a tree house for my kids. I just love to build things and see something come from my mind into the real world. I do a lot of 3D printing. Actually, when I worked at Disney, all of my job there was 3D printing, making robots for assembly lines. So I think it's the ultimate. You know, you start out writing "Hello World," you build up to, you know, here's this great, you know, e-commerce site that can take thousands of transactions per second or millions of transactions per second. And then you move on to, you know, going snowballing effect. My snowball effect led to building things in the real world. This is how it actually works. So when you say something to wall things, there's a Node.js application that runs on Elastic Beanstalk, and it listens for that. Whenever it gets hit with a request, it comes back with a JSON response, and that JSON response is interpreted by the ESP8266, which is a small chip that I'll show you later. And then the ESP8266 turns that into the lights turning on. Magic, right? The lights themselves are special. So they may look like normal Christmas light bulbs to you, but there's actually a chip on every single bulb. And what this chip does is it decodes timing. The ESP8266 can communicate really fastly over this wire, and the specific timings is kind of like an address to each bulb. So as it sends data out, each bulb is listening for its address, and it can parse out the whole stream of data that it sends to find its one little color that it needs to be. I know this is a lot of graphs and everything, so I wanted to pass these around so that people could actually inspect them. I don't know how y'all want to do it, single person, multiple people. And as you saw, when I unplugged these lights, it really didn't care. It just keeps on working, and that's because those lights were at the end of the chain. They were considered extra. So as I send out data, each one of them reads its data and it sets its color. It could care less, about any other light that's on the system. Building this thing was fun, a lot of work. So on the left-hand side was my very initial getting these things lit up. These are called WS2811 bulbs. A lot of people have heard them called NeoPixels from Adafruit. And in the left-hand picture, you can see that they don't have the bulbs on them or anything. They're just right out of the box, plugging them into a breadboard, trying to get it to work. I initially had to get it to work with an Arduino instead of an ESP8266 because of the ESP8266 has some timing issues, some extra libraries that I had to put in, which we'll go over. On the right-hand side is when I got them started blinking. I was like, okay, now I can get things to blink. Then I built a small version of this, and you can see I quickly, jotted out the letters on a piece of paper and then just stuck the lights through the back of it and was like, okay, here we go. I can get everything to light up now. Then it went from that onto this breadboard. As you see, I started adding an LCD screen to it, and it was mainly the LCD screen I started to add to it was for debugging because I couldn't figure out what was going on with the state of the thing. So I was like, okay, let's display something on it so I know when a tweet's coming in or when a LED lights up or not. So I had a lot of stuff going on this LCD. And then this is just a picture of it hooked up to the actual board, so you can see I was at my kitchen table. I have a great family. My wife and kids are very great to allow me to work on something like this at the kitchen table. I've talked to mechanics that their wife lets them like break down engines on the kitchen table, and I'm like, whatever works for you. At least mine's a little cleaner. Doesn't leave a residue most of the time. All right, so WS2811s come like that, or come like what you saw without the bulbs. So I needed to be able to have the bulbs. Luckily, this Christmas party got notified around November, so I was able to go out and try to find C9 bulbs. But I tried to find C9 bulbs like was on the show. Because the show had, a very specific looking bulb, and it was frosted and lit up really nice. And I never could find their type of bulb. And I think what they did is instead of using clear bulbs like I do, is they used colored bulbs and just lit them up and just changed out the colors in between scenes. But my bulbs are able to light up in millions of different colors, all at the same time. So because I couldn't get C9 WS2811 bulbs, I had to make them. So on the left-hand side is me starting to disassemble a set of C9 regular Christmas lights. And then on the right-hand side, you can see this is one that's finished, but in behind it is a whole set of, just clear C9 bulbs.
The light inside the housing.
That's right. So on the first picture up here is all of the leftover trash from me clipping all of the bulbs and breaking them apart. The middle picture shows one lit up, so you can kind of see the chip right underneath it. And then right after I finished building all of these bulbs, I found out that the wall that we were going to have built, the bulbs wouldn't stretch far enough apart in their current configuration. Yeah, to fit the individual letters. So I had to cut each one of them and then solder on extension cables to them, which is great because I can take these apart at any spot and then plug them back together. But it sucked because I had to cut and strip and solder 96 connections per channel, which was a lot. Don't worry, no bulbs will be harmed this year. That's right. Well, the year before that, it was flame-throwing pumpkins, so I think I'm going to go back to the flame-throwing. This was the final setup at the space that we went to. So we had it in behind a couch, just like it was in the show, and it was kind of dark. And then I had the extra lights that's being passed around, kind of strung up on a column. So it was like when an incoming tweet come in, the extra lights kind of went down to it because it does this pattern across it. So it kind of looked like, Will was walking up to the board and then he'd start touching numbers or touching letters. After I built all of the stuff, everything that we looked at so far was, construction. There was also a lot of coding, a whole lot of coding. So that's what I wanted to get into next, was the actual code that runs this thing. Let me see. So I guess this could be demo time. All right. How many in here like Visual Studio Code? All right. Visual Studio Code is awesome. Yeah. Wow, that doesn't give you a lot of room, does it?
Okay. Are those actual Unicode emojis in your configuration file, or?
Yes.
Okay.
But keep reading them.
What?
But keep reading it.
Oh. Oh, come on.
Nice. Like I'd give y'all my Twitter key. All right. So Visual Studio Code allows you to debug Node.js applications, and I know a lot of people don't know how to inject environment variables into it, so that's why I put this one on there. You can also do it with a .m file to inject environment variables. But anyway, here is the actual application. So Twitter actually has an NPM module, doesn't everybody, that you can just use to parse tweets. So I actually have a bunch of constants up at the top of this file, like they're setting up a port for it to listen to. This is the Node.js application that's running up in the cloud right now. So
You said this one was Elastic Beanstalk?
yeah, it runs on Elastic Beanstalk. I do have it Dockerized, but I hadn't used it in Elastic Beanstalk with it Dockerized. I used it locally for that.
Why is there a logic between the numbers and letters?
Lines? Huh?
Different rows.
Oh yeah, it's just readability.
No, it's like it goes from 25 to 18 and it jumps down to 9.
Exactly. So this was the point that I was going to make, is it starts at A as 25 because the very beginning of the chain.
We're going backwards.
Yeah, the very beginning of the chain is Z.
Gotcha.
But if you notice, when you get to the end of H, then it has to jump over to Q instead of trying to wire it all the way over to I. So the enum.
Position on the strand, not in the alphabet.
That's right. So this is the position in the strand and not the alphabet. So what I had to do is set up each one as a number and create a server that checks the latest tweets. And this, of course, has a key to check WallThings tweets. So it just goes out and looks for mentions from WallThings. There's where I'm bringing in the Twitter secrets and keys.
You're not going to show us that environment file?
What's that?
You're not going to show us that environment file?
No. I didn't have time to turn that. You can't do emojis in Bash. All right, so then we pick up a new Twitter client, screen name's WallThings, look at the check latest tweet function. I'm actually storing the last tweet so that I don't have to go out and pull it each time, but I also wanted to store them to have a historical record. I used to put them in Elasticsearch, but I don't know if y'all run your own AWS, but it costs quite a bit to run Elasticsearch, especially when you start getting into like a M2, 4 M2 EC2 instances. So I brought that down. Now I store them locally and then go out and pull them. So it client.get status mentions timeline. So it's going out and getting the mentions from WallThings. And then we just pass out the link. That was some debugging stuff that I left in there. And then for each tweet that comes back, I do a little bit of, I make sure that it's English, and then I make sure that it contains the word say with colon in order to display on here. Then we store that tweet, make sure that it, if it's stored, then we pull the stored one. then we pull out a regex of the actual word that we want to. So it's not going to go through and say sentences. I was only interested in the word right after say colon. So that's what this does, is it pulls that back out. Then we go through that and match it to the enum. So I uppercase all the letters and then match it to the enum that was above to get the numbers back out of it, or get an array of numbers. We'll push that into an array, and then we return it. So we return user, tweet, and char array. Now, all right, so what this does is it pulls back that. So that was the one that had tweeted last with say in it before I started talking. So let's see who cussed. All right. So this was the last tweet that come out. And as the ESP8266, which we'll look at its code, as it goes up and looks at it, it's only really interested in the chars, and then it uses the user and the tweet to display on the LCD. So let's look at that code. Mouse. All right. How many in here have ever done a IoT project or have used Arduino? Sweet. So this is a NO file. Arduino is done with, I think it's wiring, which is like a C++ derivative. So what's that? Processing, thank you, not wiring. Wiring is the GUI thing, right? No, processing is the GUI, the language is wiring. So anyway, it looks like C++ code. Up at the top you have some includes to include all of the libraries that you need. So you include Arduino.h. I'm using an ESP8266, so I bring in the Wi-Fi and the client. The special notation there is that define. This defines the node MCU pin order, and I had to put that in there because I'm using a node MCU chip. So I had to define that, hey, this is going to be a node MCU chip before I brought in the ESP8266 libraries so that they could read that. SPI is the communication channel that it uses, serial port interface, I think it is. And then TFT eSPI is how it's running the TFT screen or the touch screen on the front. Arduino JSON is ordered to parse JSON. FastLED is the actual library that turns on the lights. It handles the timing and the communication from the SPI bus to the lights. And then JPEG decoder is how I get that cool little Stranger Things image on the TFT display. And then StrangerThings.h, let me see if I got it on here. Nope. Y'all have got to see that one. StrangerThings.h. Yeah, I don't have it open as a project. So if you ever wondered what a JPEG looks like as hex characters, that's it. Stranger Things or StrangerThings.h actually brings in byte code for a JPEG so that I can use it with the LCD screen. All right, so now we get into the codes. I define some more things, like the number of LEDs that I'm using is 50. It really doesn't matter what your upper limit is, but I think if it goes over 25, you want to jump to 50 so that the timings are correct. The data pin for the actual LEDs that are hooked up to. And I forget why I defined that. Oh, I should have marked that out. Great. So the previous one's my phone. Please don't hack it. But if you see FBI van 22, that's me. All right, so we bring in num LEDs and define CRGB LEDs. Then we set a G hue. That's the animation that happens before it has a hue color or a hue start color that we go by. I just told it to go by 0. Then we initialize a JSON buffer so that as I'm pulling in the JSON from the web service, it can handle it. Since it's a C-type language, it doesn't really handle strings without buffering and indexing them and bit banging, so that kind of sucks, but it's great. Then we initialize TFT eSpy. We begin a serial connection. So the serial connection is so that I can debug it on my computer. So it kind of communicates back and forth. And anytime that you see serial.print, it's me sending a message back to my computer so that I can look at it in a terminal while it's connected. Still defining LEDs. Then I set their brightness to 100. So if you haven't messed with Arduino at all, every microcontroller does this. You have a setup and then a loop. So the setup, you want to go through and define all of your things, like here's my starting color, here's how many LEDs I have, where do I go find my picture, that kind of stuff. And then you have the loop, and the loop runs just as fast as it can over and over and over again, and that's what differs a microcontroller from a regular computer, is it just continuously runs that loop as much as it can. It runs setup one time and then it runs a loop. So right now all of this is in setup. So I'm setting up the screen, connecting to Wi-Fi, displaying text on it. And if you see this draw array JPEG, that's setting up that Stranger 40, the bit file that we saw earlier. And drawing to this screen is pretty fun. So you start out with a cursor, and then you move the cursor around to wherever you want to. You draw something, it ends at a position, and then you got to move it again and draw some more. So you'll see me say set cursor quite a bit, and then I just say print line connecting to Wi-Fi, and that puts connecting to Wi-Fi on the screen. This is the starting up the Wi-Fi server. So I'm connecting it in STA mode, or just checking to see if the ESP8266 can connect. Then we go to actually connect to Wi-Fi, print out my SSID to the computer, and then I do call Wi-Fi.begin. So this creates a connection to a Wi-Fi network. So this kind of just sits here in a loop and checks every 500 milliseconds to say, are you connected to Wi-Fi? Are you connected to Wi-Fi? Are you connected to Wi-Fi? And if it's not, then it prints out a dot in my thing. So if I start it out and tell it to connect to Wi-Fi, and I come back after taking a drink or something, and I see a bunch of dots on my screen, I'm like, oh, it never connected to Wi-Fi. If it does connect, then it gives me the IP address, prints that back out onto the serial port. I don't print it out on the LCD, but back on the computer so that I can debug. Now we start the loop. All right. So if the hue color, the color that it goes through and changes the lights to when it does the animation to begin with, if it's over 100 during this loop, then it resets it back to 1. If you remember, it started out as 0. So it'll show 0 one time, then it'll assign a color. So one of them will be blank, and then one of them will be a certain color, and then it goes up from there. Got to set the rotation to the screen, draw a rectangle, fill the rectangle with black, then I go get a tweet. So I can't jump. We'll look at that in a minute then. Let's see, let's go down here to get a tweet. There's a lot more. I'll skip over some of this because I do have this in a GitHub repo, and you can go check it out on your own later.
Hopefully you didn't check your phone's Wi-Fi password too.
No, I did not. No, I did not. That was a demo talking to you guys mistake. Hopefully there's no hackers in here. All right. Hopefully y'all are all hackers. There you go. All right, so this is get tweet. I'm defining HTTP as the HTTP client, and then I go and get StrangerThings, wall things, the Beanstalk instance. I didn't buy a domain for it because nobody actually sees that but you guys. So I just used the Elastic Beanstalk URL. Goes through and gets the tweet. If let's see.
Interesting.
Yep.
Negative on error?
What's that?
Your comment about it's going to be negative on error.
Yep.
I guess because it defaults to negative, or what if your server goes to 500?
It would still be a negative.
Okay.
Because it's not really, it's an enum. So,
Okay.
So if the HTTP code basically goes out and gets the code, if it comes back as okay, Then we get the string from the payload, which is the string, print the payload out, and then return the payload. So that's all the HTTP code. So as you can see, it's not as easy as like Node.js where you just go, okay, give me some JSON, let me do some stuff with JSON.
How long did all this take you to get working?
I think 3 days, but it was mostly, nights.
Have you done anything like this before, or was it all?
Oh yeah.
Okay.
So 3 years ago, I built a tweetable Christmas tree and stuff like that. So I was used to how to work with this stuff. All right, so it comes back as string JSON. We set up the dynamic buffer that, the buffer size that we defined earlier. Then we actually go through and parse it. JSON buffer.parse object parses out the JSON so that I get the root. Then we pull out the things that we're wanting to pull out. So the root user and the root tweet, if you remember from the, if you remember from this, user and tweet were keys within there. All right, and then we do a lot more of that set cursor and do some coloring, set the text size. So basically what this is doing is drawing this on the LCD screen. So all of this draws the username and tweet onto the LCD screen. Then we start to get to the fun stuff. So now we're looking at the root, which is the JSON object, and then chars. And this almost reminds me of a Ruby hash, where you, as you're parsing it. Delay means delay, as it's just waiting for a little bit. And you have to set delays every once in a while, because if you don't, it'll trigger a watchdog timer on the ESP8266 for the where it's connected to Wi-Fi and streaming. Every once in a while, if there's not a delay, there's a timer on it that'll just kill your application because it's saying you're not giving me enough time to keep the Wi-Fi connected. So that's why you see a lot of delays in here. But now these delays are for animation. So whenever I get a tweet, I set black, set white, set black. That's why I said epilepsy. People, if you have epilepsy, close your eyes because that thing will blink. Then it prepares the message. We get each of the values as chars, and then we turn the chars turn it into addresses that I need to parse through. And you can see down here is where I'm actually parsing through them. Sorry. This is where I'm parsing through them. So blink letter, current char. So as it goes through it, it will blink a single letter. So all this does is blink the one letter. So you'll see it turns it red, then black, and then back to red. Somebody tweeted a long one. All right. So red to black and then back to red. Let's go back up here. Then it goes through each of the LEDs and turns everything white, so it kind of turns them all on. Waits a quarter of a second, sets it black, and then it shows a rainbow. That's your rainbow. And then it changes the hue so that each time it shows this rainbow, it's a different, each one of the LEDs will show a different color. So it's never the same color. Wait 5 seconds and then do it all again. And that's the code for the actual board. So now what I'd like to do is see if I can do this, and then I'll answer some questions. So I just got, what's that?
You've been answering questions.
Yeah. Let's see, new screen recording, and do the FBI van.
So do I understand correctly that right now it's using the screen is using, and microcontroller is using your phone as a hotspot to connect to the internet?
Yeah, that's why I've got it plugged in, because it was killing it. Come on. This worked before. Give me just one more second. Oh, I'm on the wrong, never mind. I know you can't see what I'm doing, but what I'm trying to do is bring up a video of of my phone so that you can see what I see on the screen. All right. So I found this to be a good way to kind of show you what I'm seeing on here, and I'm hoping all of this is long enough for me to be able to pull this over and actually show you some of the board. Actually, I'll just disconnect it for now. I'll plug it back in so that y'all can tweet at it in a minute. All right, so this is a sandwich of boards. Let me see if I turn it sideways, if it'll. No, it doesn't change it. All right, so it's a custom board with a lot of wiring, but I made everything modular so I could pull it all apart. This is an ESP8266. This is a model 12. There's a lot of variants of ESP8266, but this one in particular has a USB debugger right on it, an FTDI chip, so that I can talk right to the board and don't have to reset it and all of that other good stuff. So this one's a good variant. It's called a Node MCU. And if I take that off, there's the actual model, and you can see it's got some hot glue on it from where I was gluing from lunch. But it's a small little board. Just takes a micro USB cable, hook it right up to your computer, and then you can program it. Thanks, AngVA. All right, and you can see I soldered onto this breadboard and there's a bunch of little connections there. Some of them go over to the 3 wires that come out to the lights. And if I take the other side off, you can see this is a TFT touchscreen that you just buy for an Arduino, and I modified it so that it would work with the ESP8266. If you look at that side of the board, you got power coming in, and then you got a bunch of pins kind of squashed over, and a couple little header pins, but this is where the TFT actually goes into. So it's all modular. You can unplug it and plug it back in. I didn't actually post any of the schematics or anything on this. So let's see if I can hook this back up the way it's supposed to go.
Did you see you modified the touchscreen?
I did.
How's that?
Not the touchscreen shield itself, but just the wiring between it, so that it would wire to different pins, because it was made to hook onto an Arduino. All right, there we go. When it fits, right? All right, and I'll go ahead and answer any questions that you might have, if you have any. Just.
The addresses on the bulbs, did you assign those addresses, or do they come that way?
So the addresses on the boards are not actual addresses, they're just timings. So the number 1 bulb gets the first address, which is the one that's connected here. And then the bulb after that will get the next address. So it's all about the timing.
Does it know if it's first or second or third?
It's just the chip. As it goes through, it pulls out 24 bits, and then it'll move on to the next one and pull out 24 bits. Yeah. The first one it hits is the first one.
How much memory does the program take up? You know?
How much what?
How much memory does that take up to run all that?
I don't know, actually, off the top of my head. I do know I was running close to the limit on it, but I don't know specifically.
Anything you want to do differently?
If I had more time, I would actually build a little PCB for this, but I didn't, so I didn't. I would probably add the bad word filter to the other thing, because I know that's going to be a thing that happens as I give this talk.
I haven't seen any actually out there.
Oh, okay, good. Yeah, yet.
Well, my phone's off, I don't have a Twitter account, so not me.
There you go. All right. I would also put an index on these so that I knew which one was front and back. Because now it's not lighting up. See, I would have definitely put an index on the pin so that I knew which way it went.
Oh, so it's so modular that you can plug it in the wrong way and it'll still fit.
That's right.
Okay.
Yeah. Which I think it's supposed to go on this way.
I like that about building my computer. I see it plugged the wrong cable and the wrong port.
That's right. But on this you can. All right.
If
And
you wanted it to make sense, like to start with A, could you go and suck in all the addresses on the first pass and then arrange them and
Oh, yeah.
A and K them so that like A was 1, B was 2, and so forth?
I could have, yeah.
So that you could read it, like you could read the numbers and see what the text is.
Yeah.
So you could, there's no problem.
You talking about to have the enum up there make sense?
Yeah.
Yeah, to where A is 1. You could have, you would have, on the ESP8266, you would have had to reverse the number. So you would have had to change the number on the array. You would have had to been like,
Do that, it's not like that's
Couldn't you have just started with A?
I could have plugged it in up there.
And ran the extra wiring from H to I and.
Well, it does run one way, but I could have started with A and ran it the other way.
And then
Yeah.
when you got from your H, go your I instead of going from your Q to your H.
If you'd have to jump
Exactly.
all the way down, just trying to make it like
Yeah.
a show.
Mhm.
But wiring them.
That's right. There we go. And I've got it powered off of a little USB battery pack, but it does take 12 volts to run the lights. So that is another piece of trickery in there, is that you had to pass through the 12 volts to the lights without it interfering with the 5 volts for the other.
So why did it start flashing flashing the letters when you plugged in? I thought the initial was the rainbow. The initial was the tweet. Did I misremember the code?
No, it was already running when I plugged in the lights.
Okay, got it.
So,
running before you plugged in the lights.
Yeah, so if I unplug them now, it's not going to do anything, but this thing still runs.
Gotcha.
And it's still sending messages. So then I plug it in and it's connected up. Then also, if I plug in these, then they just start working too. How much what? I have a lot. I have a lot. I have 4 3D printers, a CNC machine, a laser cutter, and a bunch of other just crap. Go ahead.
That's with like multiple people doing it at the same time.
Just did.
I actually checked Twitter for mentions, and there has been like a gap between messages, like enough for them to show. I was just
Yeah.
wondering what happens if like everybody starts doing it at the same time.
Whenever the ESP8266 asks the server what the last tweet was, it'll get whatever the last one at that time.
Basically.
That's right.
Oh, so they'll fall off?
Yeah, they'll fall off. So if it, like the tweet that showed up when I first plugged it in was from February. So it'll pick up whatever the last one was. Go ahead.
So what you're saying is I can surprise your kids by when you forget to plug this in at home and you get some message from code on the beach.
Yeah. The next step for this was I was going to try and take pictures of it with with each individual lighting up, and then create like a node thing that would take your tweet and then build a GIF out of it and send it back to you. Go ahead.
Any idea on connected to a chatbot?
To a chatbot, that would be awesome. But I really like the idea of Twitter being like the upside down. So it was like somebody was in the upside down trying to talk through it.
Dark world that mirrors ours.
Exactly.
Does it blow up if there's, I guess, how do they handle parsing non-ASCII characters? I don't remember seeing that in the code. You probably did show it to us.
I did. There's a lot of code, and that's like I said, I put it on GitHub so that y'all can check it out. But where
Already
is
have
it?
your regex in there, it's
Yeah.
just pull out just the word.
Yeah, so it just pulls out a word. So if there's any non-alphanumeric or alpha characters in there, it'll just throw them out. Now, another thing that I wanted to add to this was the bad words filter, but I just was lazy and didn't do it. But there's a bad words filter that'll turn all of the bad words into, stars.
Is that a Twitter thing?
No, it's an NPM module.
Okay, NPM model.
Yeah, so
So turn one and not bad words.
that's right.
Bunnies. Sunflowers remix.
I had no idea that there was so many different ways to say boobs. There was like boobs that was like eight zeros long.
So one thing I noticed, one of my tweets had 2 spaces after the column,
Mm-hmm.
and I noticed that the board started kind of flashing, and like it wouldn't show anything.
That's right.
Just like flash and reset, and then like started working fine after I fixed my tweet.
Oh, okay.
But I just haven't maybe look for a new regex.
Yeah, this should take any of the first word after say and then nothing else.
I think because of 2 spaces.
Oh, that's right. Yeah. So if you had multiples, it would pick it up. Yeah. So yeah, it would if you had a 2 spaces after say, it would just not say anything.
Yeah.
Yeah. Yeah, that's right.
Nothing in there.
Exactly. So it's a issue with my regex. I should have probably backed it up and put a different thing. Yeah, yeah.
Change the word basically.
Mm-hmm. God, I hate regex. Go ahead.
You start developing from that. How did you? Because there's multiple different components going here. What order did you develop those in?
So I developed the board first, and I got the LEDs working and got it parsing JSON. Then I developed the Node.js application. Go ahead.
Did you pick JSON for a particular reason? You could have just said strings to it, right?
I could have, but I wanted to send an object to it, and I really wanted the ESP8266 to parse JSON as like a web service and be able to connect other things to it. So that when I built the Christmas tree, it only sent strings through. It sent a color variable, like a hex value, and it was able to do that pretty easily. But this one was more complicated message. I had the whole enum, or the whole array of numbers and everything. So I just wanted JSON. Go ahead.
I know it would be a lot work, but do you think of just using white sandpaper for frosted bulbs?
I've thought about that, but yeah, of the 3 days, 2 of them was building those bulbs. Go ahead.
Have you ever worked with like Particle or like Tessel to write Node instead of writing more C++ kind of stuff?
Yeah, I had never worked with Particle, but I write Node.js stuff all the time.
Yeah, I was just saying some of the boards that you write Node directly to them instead of switching between Node.
Oh, you're talking about on the ESP8266. Yes, there's a Node.js version on it. I'm just used to Arduino with microcontrollers of this caliber. Other than that, I've typically used .NET or Python on a Raspberry Pi. All right. Well, it looks like I'm just 10 minutes under. I'll give you 10 minutes of your life back. Thank you very much.